Next talk, and we're going to have Ian Mercer, who is going to tell us about a smart house, which is pretty cool. My house is not that smart.
Thank you. I'm going to talk about having fun with .NET. Forget about your work. This is a fun project. This is my side project. It's a little side project I started more than 10 years ago. It evolves all the time. I'm always adding new features to it, deleting features. A personal project like this is just a great place to experiment, try new stuff. Try this new Nuget package. You don't need to wait until it's stable, until you're allowed to use it at work. You can just party on, try them, rip them out. I've probably deleted as much code as I've written that controls the smart house over the years. But let me first of all describe what I mean by a smart house. If I can advance slides. Okay, we went to presenter mode and nothing happened. Seriously? A smart house is aware. It knows what's going on. There's a current crop of smart home products out there, IoT products out there, which are little more than remote controls. You push a button. If your smart home interface looks like this, it's not smart. If you have to tell your house that you're at home, it's a dumb, very dumb house. Our house is aware. It knows what's going on the whole time. It's also not a smart house if it just alerts you all the time. Garage door open, garage door open. Anything like that that I've tried, you quickly turn it off. It just becomes annoying. A house needs to be aware of what state the house is in and how it should deliver that alert to you. Often the alerts that my house delivers are subtle cues, like subtle lighting changes, or like when somebody comes down the drive, you get this subtle bird tweeting sound coming over the speakers. Visitors to the house don't even notice it. They think it's a bird outside. We know what it is. We know it means somebody's just come down the drive, and the dogs know what it is, and they'll go off running to the front door because, you know, Pavlov, they've been trained to recognize that noise. So a smart house is aware. Our house is aware of what's going on in every room. This is actually the web interface. This version is the Angular JS version with SignalR in the background, pushing real-time updates. So as somebody walks over a particular floor, that room will light up in bright green and then gradually get dimmer. So at a glance, you can see what's happening in the house right now and what's been happening over the past half hour or so. Last weekend, I had to go rewriting that in React using RxJS and still using SignalR as the back end. But for the most part, you don't need a user interface. The house is the user interface. The house has hundreds of sensors, over 200 sensors scattered throughout. Motion sensors, magnetic sensor by the driveway, contact sensors. And as you walk around, you're triggering these all the time. By the time you've come through our front door, you've triggered 5 sensors coming down the drive, motion, doorway, beam, floor. This is one of my favorite sensors. It's actually a strain gauge that goes under the floor. It would work fantastically well in the ballroom here. It would cover a huge area because it's measuring the deflection of the beam as you walk around. They're invisible. You can set them so the pets don't trip them, and they're very reliable. The house also, takes advantage of the fact that we're all carrying this little transponder around with us the whole time, advertising our presence. So it sniffs Wi-Fi, it looks for any device that connects to the Wi-Fi, and to encourage other devices that come into the house to connect, I have a couple of extra SSIDs like Google, Starbucks, and CTAP-free Wi-Fi, because I know that most people's phones will automatically join the network with that, and then I get their MAC address, and then I can track, visitors coming, I know which of my kids are home, which of their friends are there with them. The house also interfaces to lots of external services. It brings in the weather from NOAA. It brings in the ski conditions, the pass conditions, because there's no point telling me there's fresh snow at the pass if the pass is closed and I can't get there. So it tracks both of those, tells me when the best time to go out and ride my horses. And when it gives you the weather, it doesn't give you the usual, the high today will be blah, low will be blah, boring stuff. It actually does a diff. What was the weather yesterday? What's the weather today? And it says, hey, it's going to be a bit warmer today. That's all you really need to know. When we converse as humans, we omit all of the stuff we already know. Computers need to get better at sort of understanding who they're talking to and responding that way. In the Pacific Northwest, triggering your lights by time of day is a pretty stupid idea. It's not a great way of knowing whether that light should be on or off. One of the other sensors I have is a little photocell sensor, which is measuring how much light's coming in the house, and based on that, it will decide. So sometimes you walk into the kitchen at midday and the lights will come on, because in Seattle, it can be really dark at midday. There's a lot of data. Triggers per minute, 5 triggers per minute. Over a course of a day, these are all the triggers coming in, color-coded by room, over 100 gigabytes of data growing all the time. I'm hoping one of the F-sharp machine learning people is going to approach me and ask, can we use that data? Because I've started trying to do some machine learning, but time series, recurrent neural networks, with a span of a year or a month or a week or a day, it's going to be a challenge. But long term, I hope to add machine learning to it. Smart is hard. Just the simple decision of turning a light on. Anybody who tells you that you can use if this, then that to control the lights in your house is kidding. First of all, the latency is too high. When you walk into a room, you don't want to wait 250 milliseconds for the light to come on. It needs to be much faster. But secondly, the decision to turn that light on is actually predicated on a whole bunch of different factors. The sunlight I mentioned, time of day I mentioned, type of room, how bright it comes on. When you walk into the bathroom late at night, you don't want to be blinded by the lights. They come on dimly. How many visitors? So the house tracks visitors, people who came down the drive, through the front door, lots of activity in the kitchen, thinks we've got visitors. And the house actually acts dumb when we have visitors. It acts dumb so that I don't have to explain to you why that light just went off over there. Because you'll be like, whoa, what just happened? And I'm like, it's easier just not to do anything. Just pretend to be dumb until they've gone away, and then you can be smart again. I think the house still needs all of the manual controls. When there's somebody staying in your house, they need light switches, they need a thermostat control. You don't need to, you shouldn't have to give them a manual and get them to install a smartphone app before they can, stay in your house. So we still have the light switches and the thermostats, and the computer lets you set them. The kids can set the thermostat to 85 in the winter and 37 in the summer or whatever they want. They can open up all the doors with the AC running. But over the course of the next hour, it just takes over subtly, puts it back to where it should be, because it knows best. It knows better than my kids what temperature the house should be at. So let's talk a little bit about some of the .NET code behind this that's evolved over the 10 years. Some bits of this are on my blog, some of it's on GitHub. I haven't made the whole thing open source because, this has been going on for 10 years, and 10 years ago, I may or may not have thought that static was a good idea. I may or may not have thought that two-way binding and inheritance were fantastic ideas. Of course, I know better about all of those things now. We avoid all of those. So like Sebastian mentioned earlier, a graph is a fantastic way of representing this. The house is it used to be represented as a tree, and then I get all these problems with trees. You can't represent things, so it's now a graph, and you can have any kind of relationship between two nodes, whether it's a sensor in a room or between two rooms. And that's the complete graph of the house. Zoomed in on a little bit, you can see how dense it is. Each node is a device or a piece of logic controlling it. Graphs are an awesome data structure. I have an internal in-memory graph or on-disk graph, and you can use simple queries, find all the lights in the room, transitive closure, follow this same link type as far as you want to go, find me everything in the house, or you can do pathfinding on it. Which way would somebody go if they were going from this room to that room? Can I track them and turn the lights on ahead of them as they go? And it's not just any kind of graph I like. I like the semantic web form of the graph, the triples as I call them, tuples as Sebastian called them. The fantastic thing about using a semantic web model is it's self-describing. That node in the middle, unlike a normal directed graph or like a Neo4j graph, the edge in a semantic web graph is itself a node. So now I can build another relationship on top of that that describes what that predicate is. What does type mean? What does this room connects to that room mean? And I can do another one on top of that. And since there's a language for representing this called turtle, it is actually turtles all the way down. And you can do reasoning on it as well. Along the way, whoa, that went 2. 3, stop. Along the way, I built a language, a fluent way of defining what you wanted to happen. And it's very RX-like. I kind of built it before RX. I looked recently whether I could just throw it all out and use RX. There are a couple of differences that meant that was a bit hard to do. So one of them is that it includes long-term state persistence. So you can say, then this door opens within 70 days. You know, my system's probably been rebooted 20 times in the course of 70 days as I push new updates out. But that logic still works because it saved the internal state off to the database as triggers came in and things changed. Another key thing, and I think you could do this in RX quite easily actually, is it can explain why something happened. So when it changes the brightness on this light here, as it came down through that logic, it stored the path that it was following. So it can say, I turned the kitchen light on because somebody came down the drive, then they came through the back door, and then they trod on the floor. Which is great for debugging, because otherwise, you know, a house does something unusual, and you're like, why did it do that? 2 o'clock, yesterday morning. You can just look in the log, and oh, that's why it did that. This is the bit of logic that caused that to happen. Sometimes, though, the logic's more complicated than I can express with that fluent syntax. So one of the projects I have on GitHub is a hierarchical state machine. There are lots of .NET state machines out there. I wanted a hierarchical one because that means you don't need to specify as many transitions. It's a bit like, the on state is like an abstract, on auto and on manual are concrete states. But then I can specify a rule that says when the user turns the lights off, I'm going to transition to off manual. But I'm specifying that on the on state, so it applies to all of the substates of on. And you can have transitions that, activities that fire when you enter a state, when you leave a state, either at the hierarchy level or the lower down levels. Another key thing that I wanted in my state machine was this concept of time. It's so important in the home, being able to do something after a period of time or dimming the lights. Every 4 seconds I want to, the house never shuts the lights off. It just moves them down very subtly over the course of the next 10 minutes so that you never get plunged into darkness by mistake. If there is a bug and it accidentally turned the lights off, you've got 10 minutes to get out of your chair and for it to realize that you're still there and the light should be on. And so my state machine, you can do machine.every or machine.after, and it keeps track of all the future events as a recurring thing, so it can regenerate the everyones. And it keeps track of when the next activity is. So you can actually take the state machine, persist it to disk, take the next runtime as a column, sort by that column, and you can quickly look in the database. Is there anything that needs to run? Go fetch those state machines out, give them a quick run, put them back in the database. A lot of these decisions were sort of based on history. What was this room doing yesterday? What was this, how many times did this happen today? So I created this concept of a variable with history. So a variable with history behaves like a variable. You can set it to 27, you can set it to 35. And what it's remembering is the time you set it and what you set it to. You can ask it what the value is, it's 35. But you can ask it, what was the value 5 minutes ago? What was the average value in the last 4 minutes? And for Boolean, how many times did this room get occupied yesterday? How many times did this door open? And then, when you're prototyping, you're just parting on, and you want to add another field to some object, and then you have to go to your database object, and you add your field there, and you go to your DTO, and you add it there, and you update AutoMapper if you have to, and then you've got an interface on it, so you have to add it there. It became a bit tedious. I got bored of writing, database objects and DTOs. So I came up with this idea that you can take a dynamic object, and using this wonderful Nuget package called impromptu interface, you can get a dynamic object to act like an interface. So I can take my dynamic object to say, act like an animal, and give you a name. And I can take that same object and act like a flying animal, and you've got 2 wings. And it's kind of multiple inheritance. I can inherit as many interfaces as I like, which solves the whole, bats fly and penguins don't fly problem with normal sort of class hierarchies. And when you set it to the database and bring it back, it comes back as an I animal and an I flying. You can say, is this an I animal, and do something with it. So that's quite fun, because as things evolved and added new interfaces, it was just very easy. No migration scripts, no classes, classless persistence. Running 24/7 is hard. System would crash for years and years. It's pretty stable now, runs for months at a time. Try catch everywhere, components, one component fails, you can't stop the lighting from working because the sound isn't working. You have to build resilience in there, exponential backoff everywhere. There are 2 deadly exceptions in .NET. We'll talk about those. And the other thing is you can't just fire threads off. Oh, just fire a thread off. Because you fire off 10,000 of those and the system dies. So a lot of it has long-term threads that are just running the whole time. Exponential backoff, there's lots of exponential backoffs out there. I actually don't like the ones where you pass an action in, because that just messes up your stack trace when you're trying to see what happened. So I separate the idea of exponential backoff from the logic of actually handling that. The 2 deadly exceptions, Stack Overflow and out of memory. You can't catch them, you can't do nothing with them. And related to that is sort of infinite loops. I've seen big web applications where a developer wrote a while loop, while some condition, and he was pretty sure that that condition would eventually go false. Well, he happened to be wrong, and happened that inside that loop nothing was happening. So now you've got one core of your web server just spinning in this loop, and then somebody else hits that same bit of code, and now you've got 2 cores, and pretty soon your whole website is dead. So what I tend to do to try and prevent that from ever happening is always put a limit on anything that I can't be absolutely sure it's going to terminate. Massive limit, minus, minus, throw an exception, unbounded loop. That stops the system from dying. At least it gives you a stack trace that you can see where it went wrong. And then, partway through my project, I decided I wanted to be able to talk to my house, to chat to it. And so a little side project lasted a year or so, still going on. I wrote a natural language engine for .NET, because I couldn't find anything out there that did what I wanted. Most of them are sort of statistical, part of speech, taggers, and sentiment analysis, and all this stuff. I wanted command and control. I wanted to be able to parse this thing, play songs under 4 minutes long, added this week in the basement, and I wanted to be able to understand that expression and start playing those songs. And so I built this natural language engine. And you can ask it about the house, and it even integrates with Asana. You can say, I need to buy coffee beans, and it puts it on your Asana shopping list. So chat-based, there's a library available. And the programming model, I really didn't want a whole bunch of XML to configure this thing. So I actually copied MVC. And so you create an action method. And unlike MVC, you don't need to specify the route. You just give it the words that you want it to recognize, and you can give it the whole class of words. So turn 4 is actually the 4th meaning of turn. I'll mention in a sec. It integrates with WordNet from Princeton University, so it has a whole dictionary of thesaurus in there of 70,000 words. It understands synonyms. So when I say turn 4, I actually mean turn and all of the other words that mean the same thing as turn, as in turn on, not turn around a corner. And then building area, it's a strongly typed system. It'll actually give you the building area, the room, the floor that the user mentioned, and it gives it to you, calls this method. You can just go in, turn all the lights off, respond with some answer. It doesn't have to be pure chat. You could update a web interface as well in response to messages coming in. And so that was kind of a fun diversion for a few years. Whole of WordNet. So you actually get IntelliSense for meanings. When you hover over the word name here, it'll say a language unit by which a person or thing is known. So you can make sure you've got the right meaning, which matters because it has different synonyms. Expressions, this turned out, this probably another year actually here, under 4 minutes turns into an expression, a token expression as I call it, which is a bit like a .NET expression. Duration is less than 240. At this point, it doesn't know what to bind duration to, but then you give it your domain model as well, and you can call, convert it to a .NET expression, to a SQL expression with date part and all that other stuff in that you have to do for SQL, or to a MongoDB expression. And so, for example, there, play songs under 4 minutes added this year, but not Miley Cyrus. It compares that as the duration, blah, 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 and then it turns that into that Mongo query. So you see the duration there is a less than operator in Mongo. The date created is actually a less than and a greater than. You're trying to find it within a range. And Miley Cyrus, it actually recognizes that and turns it into an actual entity ID, object ID. Time was phenomenally hard. English language is horribly ambiguous. Monday, next Monday, last Monday, every Monday, which Monday did you mean? Often you need to get the context of the sentence around it to understand what that is. So I created, date time really doesn't cut it. It doesn't cut it for date time, so it certainly wouldn't cut it for this. And so I created this thing called a temporal set, which can represent finite time, single day, group of days, months, years. Infinite, every year, every Monday. Half infinite, before or after a period of time. And these temporal sets have the ability to be, enumerate them forward or backward, even if they're infinite, turn themselves into a query, and then also understand their granularity. When you add two together, how do they add? So you can chat to it and ask it, define the third Sunday in May, and it will show you what, if you've got debug on, it will show you what's going on here. I actually have multiple chatbots. So I created one separate chatbot that's just for testing the natural language, and another one that's all about looking up word definitions, and then there's the home automation, and I'm pulling the whole music piece out of the home automation. It's going to be a separate bot. And when you start creating multiple bots, and you don't go down the path of, you have to say which bot you're talking to, which I think is a kind of a dumb way to build a natural language system, because as soon as you've got 1,000 bots, how do you know which one to talk to ask the question? So you want lots of bots all listening at the same time. Well, guess what? Now, suddenly you get the case where they both talk, and then one sees the other one talking and starts talking back to it, and then all hell breaks loose. So you actually have to build politeness into your bots. Your bots need to look at it and go, oh, he's already answered the question, I'm going to shut up. She's already answered the question, I'm not going to handle that one, and I'm certainly not going to reply to the other bot, because then we'll just get into this fight. Temporal expressions are actually a tree. You can control the lights and the heating. You control the music. You can look up across all your sources, find this word. Here's all my music. Here's all my tasks that have got that same word in them. It's conversational as well. It tracks the history. So if it's just started playing a song and you say, who is this? It knows that it just started playing something that can be described, and so it'll describe that to you. If it was a phone call that came in, it would tell you who the phone call was from. And at one point, I was like, well, on Twitter, we can all read it without the spaces. Why on earth does my parser need spaces? This is dumb. Let me just take out that requirement. So I took out that requirement, and you can now use it without spaces. What I found is that English was ambiguous to start with. It's way more ambiguous without the spaces. So it's generally not a good idea, but it can do it. You put it on your task list. You can, because the WordNet that I import is itself a graph, a semantic web-like graph, it can actually do a bit of reasoning on top of that. So Octopus, as well as being a great deployment system, is also a very interesting English word. It's an English word that has 3 plurals. Not many people know that. And you can ask it about, is an octopus a fish? And it can actually answer that question correctly. Lots of stuff, lots of libraries. Don't think I've even got them all up there. But it's just a great way to try these things out, to learn, and to move on. And I've got a few minutes left. You can track me down. If you search for World's Smartest House, you might find me. I used to be #1, but some stupid news articles ahead of me at the moment. But if you all put a link to my blog after this, I might get back to #1. It's pretty close on SEO, which of course means it really is the smartest house if I'm #1 on Google, doesn't it? Bing's a lost hope because they rank edu domains ahead of me, so I'm giving up on that. A couple of Nuget packages there. We got 2 minutes left? 1 minute left? One funny anecdote with a lesson. I have a web interface. One day I was out, my wife was home, she called me up. It just turned all the lights off. Oh, turned all the lights on in the living room and then turned them all off. And then it did it in the study, and then it did it in the kitchen. And it was going around the house, turning every light on and then turning it off. I'm like, what could be doing that? When I got home, I went and looked at the logs. Now, back then, I took a few shortcuts, and security through obscurity. I had a very obscure port for my web server, and nobody would ever guess it. But you're pretty much guaranteed that eventually Google will find those things. Google had found my house. Lesson #1, security through obscurity does not work. Lesson #2 was that you should never change state on a GET request. Because Google saw this room and all these lights, and each of them had an on link. So it would follow the on link, and then that would give you a new page with an off link, and it would follow the off link. And it was very polite. It didn't crawl the whole house at once. It went carefully, room by room, very slowly and politely, so as not to flood my web server. But it was Google crawled my house. So I now have OAuth, and I don't rely on obscurity, and I do not change state on a GET request. Thank you.